anytime we want to write an equation, we're going to write it in the form of y equals mx plus b, and we're going to have to fill in the m, which is the slope, and the b, which is the y-intercept. And if you recall, what I said is, what you first want to do is figure out what the slope of your line is, and there's going to be some sort of hint. And once you have the slope of the line, then you're going to figure out the b from one of the points or some information that they give you. Well, they told us this line was perpendicular to y equals negative 2/3 x plus b. Let's call this line line 1, and let's call line 2 the line that we're trying to write the equation of. So in line 1, where they tell me y equals negative 2/3 x plus 2, this original line that they talked about, we know that the slope is negative 2/3 because this is in the y equals mx plus b form. The number in front of the x is the slope. The slope of the original line that they gave me was negative 2/3. Since my line is perpendicular, we know when lines are perpendicular, their slopes are opposite reciprocals. So therefore, the slope of my new line that I'm trying to write the equation on is going to be positive 3/2. It's the opposite reciprocal. We switch its sign, it's negative, it becomes positive, and we take its reciprocal, we turned it upside down. So I know that the line that I'm finding the equation of is y equals 3/2 x plus b. What we don't know now is the b, but we're going to figure out what the b is because they gave us another hint. They told me this new line is going to have an x-intercept of negative 4. And we know that when we talk about the x-intercept, the y has to be equal to 0. It's on the x-axis, so the y is 0. So in other words, the fact that it has an x-intercept of negative 4 means that it goes through the point, x negative 4, y 0. So I can go to this equation and replace the x with negative 4 and the y with 0, and that'll give me an equation that will help me find the value of b. This is going to be 0 equals 3/2 times negative 4 plus b. Now this negative 4 is over 1. And if you notice, when you multiply 3/2 times negative 4/1, which you could also do using your calculator. Get used to using your calculator. Multiply 3 divided by 2 times negative 4. But I'm going to do it without a calculator. This 2 in the bottom will cancel out into the negative 4 on the top and leave me negative 2. So this will give me 0 equals 3 times negative 2, which is negative 6 plus b. And I'll bring the 6 to the other side, which will then mean that, I'm going to go over here, b is equal to 6. And now I have all the pieces that I need to write the equation of the line. I'm going to write it right over here. I don't want to go too low. It's y equals, my slope is 3/2, so it's 3/2 x plus 6, because my b is 6. And this is the equation of the line that you wanted. I hope some people were able to get this. These are among the hardest problems that we do this year. This writing an equation where there's so many pieces that you have to put together. Are there any questions about this? Okay. If they're not, Then let's go on to the problem that Alexandra wanted me to. Does anybody, can I erase this? Any problem? Okay. Alexandra, can you tell me the question you wanted me to do?
Yes. This question only gives you 2 points. It's 0, comma, -5. And then the next one is -5 and -1.
And they want me to write the equation of the line? What do they want for this?
They want the equation of the line using the 2 points.
Okay. All right, again, this is a common type of question. Again, another type of description of a line, and they want me to write the equation of the line. Again, when we want to write the equation, it's y equals mx plus b.
Hold on, sorry, can you say that again?
Okay. And again, the first thing we want to do is find the slope. Well, if we have 2 points, we know how to find the slope. The slope is y2 minus y1 over x2 minus x1. So I pick one point to be my first point. Let this be the x1, y1. And my second point becomes the x2, y2. Remember, the subscripts y2 means the y of the second point. And I just put these numbers into my formula. So it's y2, which is -1, minus y1, which is -5, over x2, which is -5, minus 0, which is x1. And remember, when you have two negatives, that becomes a positive. So it becomes -1 plus 5, which is +4, over -5 minus 0, which is -5. Usually we don't leave the negative on the bottom. It means my slope is -4/5. Any question about that? Okay, we know the slope. So in my y equals mx plus b, I know the equation of this line is going to be y equals -4/5 x plus b. How are we going to figure out what the b is? We're going to go to one of these points, and it doesn't matter which one. I'll take the first one. When you have more than one point, you can pick any of the points to stick them into the equation. If I stick in the 0, -5 into this equation, that means in place of the x, I'm putting the 0, because the first number is always the x. And in place of the second number, I'm putting -5. So this will become -5 equals -4/5 times 0, which I'll put over 1, plus b. Well, -4/5 times 0, 0 times anything is 0. So this becomes 0 plus b. That equals my -5, which means that the b equals -5. So now I have my equation. Y equals m, which is -4/5 x plus b, which is -5. -4/5 x minus 5. Is it clear how to do that now? So
Yes.
when you have 2 points, you first find the slope between the 2 points using the slope formula. And after you've done that, then you can go and find the b. Does anybody have any other questions they'd like to ask me before I go on to the new work that we're doing? Before we do that, I'm going to remind you that starting around 2 o'clock, you will find on Delta Math your first test. I'll give you 24 hours to complete it. I'm not giving you any time limit except that I want it done by that time. It's a total of 10 questions. Now, if you do a question and you get it wrong, you can do a second question. You will not get full credit for the second. In other words, if you did one question and it took you 2 tries, and instead of getting the full 10 points, you might get 9 points. In other words, there's a little bit of a penalty for not getting it right on the first go round. If you get it right, if you try to do another problem, it'll tell you, well, you can do more problems, but you're not going to get credit for any more, for doing more than the required number of right problems. It will be posted on Delta Math. You'll look on Delta Math, it'll say something like test 1 or Math 136 test 1, something of that nature. You'll know it's the test rather than just the assignment. In addition, there is going to be an assignment for for Thursday as well. Maybe I'll make it for next Tuesday instead of Thursday on the material that we're learning today. Are there any? Okay, so if there are no other questions, I am going to switch this over to our SI person, who is Shireen. Shireen, let me see if I can find you so you can see. Shireen, here you are. I'm gonna pin you. I don't know if everybody listen to Shireen. Shireen is our supplemental instructor. She sent you your schedule, but she's going to just talk a couple of minutes as to how it works. I'm going to check the rest, see if anybody else came in while you're doing this.
Okay. Good afternoon, guys. As you know, some of you may know me because I meet you guys last week, but for those who I didn't see last week, my name is Shireen Hudson. I am your supplemental instructor for Math 136. I sent an email early this morning about our SI session, and I sent the link. So what SI do, I'm here facilitating Professor Weinberg. So whatever questions you guys have on any topic, whether it's something recent, or something she would go over, I would go over it because I'm pretty much familiarized with her teaching style, and I have notes from when I was doing SI in her class last semester. For SI, now we're trying to cut down on paper attendance. So when you do create your username, when you click my link, I want you to put your first name, your last name, and your emplo. And from my previous experience, I know some of you may have to do like a sign-in sheet for ASAP where you have specific hours for tutoring. So if you guys have that, please let me know, and I'll let my supervisor know, because we keeping track of the attendance, and if you put your employee ID, we'll be able to forward it to the ASAP office. Anybody have any other questions?
Yeah, I do have a question.
Huh?
I have a question because I remember I told Miss Perry. I forgot her name. I'm sorry. The algebra teacher. Yeah, I remember I told her how since I'm part of the SEEK program, I already have like my own tutor. So I was wondering like if I'm still like, do I still have to like have the SI sessions?
Professor, I don't think so, right?
Question.
I don't think so, but Professor Weinberg would want you to let.
Who was that I was talking to, by the way? Let me.
I'm not sure who was it.
Who voiced that question?
Oh, that was me, Kathy Ramos.
Kathy. Okay, Kathy. So I don't know if I thought I answered you in the email.
Yeah, she said that she will contact you.
And somebody did from the SEEK office, somebody contact me, and she's going to send me the attendance. And if you attend those sessions, I'll give you the same credit you would have gotten by attending SI sessions.
Okay, then. Thank you.
Okay?
No problem.
Yes.
Anybody else have any questions they want to ask us? Okay, I have to tell you, Shireen has been an amazing help to a lot of the students. We've worked together for, I think it's certainly the second year. And she helped the students that went and did and attended her SI sessions certainly did much better on their midterms and finals and the final grades than those who didn't. So it really is to your advantage. You can always, as I said, I'm available usually between the two classes. I finish my other class at 11:40 and I start this at 12. I'm usually available at that time, but it's not very much time. I am also available from about 9:15 to 10 on Tuesdays and Thursdays. If you just log on to our regular Zoom, you'll find me here. So you can always ask a question, but really, Shireen is the one who's going to be able to give you a lot of individual attention. And she, as you know, I don't know if you noticed, I added you to my Blackboard.
Oh yes, I checked it
Okay, so
before class started.
once she's aware of everything that you're doing, all the homework, etc. So she's really on target here. So she's going to help, and she knows, as she said, she knows my style of teaching, and she's been a major help. I'm so thrilled you're joining us.
Sorry it was so late.
Okay.
We were still trying to get stuff together. That's why we started so late.
Yeah, well, everything is a little bit on the not well. At least you have something taken care of.
Yeah.
I thought it would take much longer.
Don't
Okay.
worry, for those students, if you can't attend my session times, once we finalize, my other colleagues finalize their session times, I will give you their session times, and you could just contact my supervisor and she'll send you the link for the sessions.
Okay.
Or I could get them from my colleagues.
Okay, look, you have emailed the students, right? So
Yes, I email the students.
I think you can probably email them directly from Blackboard also. I think you probably have if not, if you want me, I can also send out an email, because it's very easy to email the students from the Blackboard.
All right, I'll check that out later today.
And I tried to put you on to my other class as well, but it's so full that there's no room for anybody else. So that you'll have to email them separately.
Okay.
Okay, let's go on to what I want to do now. Okay, we are now going back to what we had started talking about on Thursday, systems of equations. Now, this is not, what we're doing right now is not part of the test that you're going to be having. The test is chapters 1 and 2. What we're covering now is chapter 3. Now, just as a quick reminder of what we did, we had a system of equations, something with two equations. Let's say the system of equations is this: x plus y equals 3, and x minus y equals 1. And we want to solve the system of equations, which means that since these are two lines, they represent lines on the graph, they're going to be two lines. What we're looking for in a solution of a system of equations is, where are the two lines meeting? And what we're going to do is I'm going to review how we solve this graphically, and then I'm going to show you a couple of shorter ways that we could do this without even having to draw a graph, and we will come out with the same exact answer. Just reminding ourselves, let's call this equation 1 and this equation 2. Since both of these are written in the standard form, which means that you have the x, the y, the equal sign, and the number, that's standard form, probably the easier way to graph this is to use the intercept method. So if we're doing the intercept method on number 1, to find the x-intercept, we're going to put y equal to 0. And if I put y equal to 0, I'll get x plus 0 equals 3, which simply gives me x equal to 3. That means on my graph, here's my graph paper. I'm very exact what we'll have to do with it. Here's 1, 2, 3, 1, 2, 3, 1, 2, 3. When x, this is the x-intercept is the point 3, 0. Remembering that an x-intercept is right on the x-axis, the y, of course, is going to be 0. Then we find the y-intercept by setting x equal to 0. And in that equation, we're going to get 0 plus y equals 3, which simply gives me y equals to 3. In other words, the y-intercept is the point 0, 3. Here is the y-intercept, 3 up. Now, with these 2 points, I can draw a straight line connecting those 2 points. There's line number 1. Now we're going to go to line number 2. And again, it's in the standard form. Let's again use the intercept method. In line number 2, again, to find the x-intercept, we'll put y equal to 0, and we'll get x minus 0 equals 1. So x equals 1. The x-intercept is 1, 0, which is right here. And then to find the y-intercept, we'll let x equal to 0, so that we'll get 0 minus y equals 1, which means that negative y equals 1. And when I divide by negative 1 to get y alone, I'll get y equals 1 divided by negative 1, which is negative 1. In other words, 0, negative 1 is the y-intercept of the second line. And that means that second line is going to look something like this. Here is line number 2. Notice these 2 lines are intersecting lines. In other words, this is what we call a consistent system of equations. And the point where they meet is right here. The point where they meet is what we call the solution of the system of equations. And I have to read what this point is. Well, if I start over here, I'd have to go 1, 2 to the right and 1 up to get to this point. So this is the point 2, comma 1. The point where they meet, I hope I read it correctly, is the point 2, comma 1. In other words, x equals 2, y equals 1. We can either say the solution is 2, comma 1 in parentheses, or we can say x equals 2, y equals 1. Notice it is the solution because it works. 2 plus 1 gives us 3. 2 minus 1 gives us 1. In order for it to be the solution, it has to work in both equations. This is the way we would have solved the system of equations graphically. Now, it certainly shows up what we're trying to do, but it involves a lot of work. And if we're not very careful on drawing our graph, and especially if our numbers are not exact numbers like 2 and 1, but something like negative 5.5 and 1.7, if those were the two right answers, there's no way I would have come up with the right answer just looking at the graph. So I want to show you two other methods that could be used to solve simple systems of equations that will give you the correct answer, but will not involve having to do any graphing. In order to do that, just remember your answer. Your answer is 2, 1. I'm going to do this, start all over and do this a different method. Okay, we did this using the graphic method. We're now going to use a method that's called elimination. In a lot of text, probably I think Delta Math calls it that. Some books call it the addition method. Both of these mean the same thing. It's just different names used in different texts. Okay, how do we use that method to solve the equation? Well, if I take these two equations where it's saying x plus y equals 3 and x minus y equals 1, two things that are equal, when you add them, will still be equal. So I'm going to add these two equations together. Notice it'll work out very nicely because since these equations are in standard format, the x's, the y's, the equal signs, and the numbers all line up. To do the elimination method or addition method, everything has to be lined up. And of course, what's called the addition method, because we're adding the equations. So if I add the first column, x plus x will give me 2x. Plus y and negative y, when you add it, cancel out. That's why it's called the elimination method. One of the variables gets eliminated. In this case, we're eliminating the y's. And the final column, we have the equal. 3 plus 1 is 4. Now, the advantage is that once you've eliminated one of your variables, you're only left with an equation with one variable, and you solve that equation. Since there's only one variable, you can definitely solve it. And dividing both sides by 2 gives you x equal 2. That gives you one of the variables, but in a system of equations, it's not enough just to solve one. To find one answer, you have to find the answer for both variables. So what you do is go back to either one of your original equations. I'll take the first one and replace or substitute the x with 2. We now know the x is 2, so this becomes 2 plus y equals 3. And now you can solve this equation by getting rid of the 2's. You get y equal to 1. And your solution is x equals 2, y equals 1. Again, you could write it in as an ordered pair. Remember, always when you're writing an ordered pair, first put the x, then put the y. Your solution is exactly the same answer that we got before. A lot less work, a lot less guessing. It's a much more accurate method. And it's a method that's quite easy to use. It's called the elimination or addition method. Let's try another example like this. I'm going to do one more with you, and then I'm going to give you one to try on your own. Suppose I gave you this system of equations. 2x plus y equals 1. X minus 5y equals 17. Again, we have a system of equations. The two equations are written in standard form. X, y equal number. X, y equal number. They're both in standard form. Let's see what happens when we add these two equations. If I try to use addition to solve these two equations. And when I add the two equations down, don't write what I'm doing now, because it's not going to come out right. When I add the two equations, I'll get 2x plus x, which will give me 3x, plus y minus 5y is minus 4y, will equal 1 plus 17, which is 18. Now, this is certainly a true statement. I added the two equations, I got a true statement. But what happened is I didn't get rid of any variable. And therefore, this new equation is no more help than either of the first equations that I had. So just adding two equations down is obviously not the only thing you have to do when you want to use this method. So let's think, what would make this method work? How could we use the elimination method to solve this system of equations? Well, let's arbitrarily decide we want to get rid of which variable we want to get rid of. Let's say we decide we want to get rid of the x's. We want to eliminate the x's. So what will eliminate the x's when we add the two equations? What makes a variable disappear? If the coefficient in front of each of the variables is the same number, except one has to be positive and one has to be negative. If one is 5, the other one would have to be negative 5. If one is negative 7, the other one would have to be positive 7. The coefficients in front of the variables have to be the same numbers with opposite signs. Well, we can cause that to happen. And I'll give you a method that always works. Sometimes there's simpler numbers that you could use, but this method will always work. Multiply each equation by the coefficient of the opposite equation. In other words, if I want to get rid of the x's, multiply the top equation by the coefficient in front of the x in the second equation, which is a 1, and multiply the second equation by the coefficient in front of the x in the first equation, which is 2. Multiply them by their opposite coefficients. If it would have been y that you wanted to get rid of, the top one you would have had to multiply by the 5, the bottom by 1. Notice I'm not using a plus or a minus, I'm just looking at the number first. After I've decided what number I'm going to multiply by, then I look. In order to remember, when we add them, in order for them to be eliminated, not only do they have to have the same number in front of them, they have to have opposite signs. Now, in this case, if I just use pluses here, if I used a +1 and a +2, I would get just positive numbers. But I need one to be positive and I need one to be negative. So pick one of your numbers to be a negative that you're multiplying and leave the other one positive. It doesn't matter which. You could have left this the positive one and make this the -2. And here's what we're going to get then. Multiplying the top equation by -1 will give us -2x minus y equals -1. You distribute that -1. Multiplying the bottom equation by 2 will give us positive 2x minus 10y equals 34. Now add your two equations down. Negative 2x plus 2x, that will be eliminated. Remember, our whole point was to eliminate the x. We said we want to get rid of the x's. So they have to have the same coefficient, the same number in front of them, but one has to be positive, one has to be negative. Adding the negative y and the negative 10y gives me negative 11y. Adding negative 1 and 34 gives me positive 33. And then I'm going to divide both sides by negative 11. And this will give me y equals, well, 33 divided by 11 is 3, and there's a positive and a negative. This gives me negative 3. I've now figured out what the y value is. To find out what the x value, I'm going to go to either one of these equations. I picked the first one because it's the first, no other reason. And I'm going to replace the y by negative 3. It'll become 2x minus 3, because I'm substituting for y, negative 3 equals 1. Bring the 3 to the other side. This will give me 2x equals 4. And that'll give me x equals 2. And so my system of equations has a solution. X is 2, y is negative 3. So sometimes we have to do a little bit of prep work before we actually add the equations. We have to make sure that we multiply the equations in such a way that either the x's or the y's will have the same coefficient but opposite signs. And then when we'll add it, that variable will be removed. It'll be eliminated. Are there any questions before I give you one to try on your own? Okay, then I'm going to go to the practice sheet 3 and look at example number 1 on practice sheet 3. The first equation is 2x minus 3y equals 13. My second equation is 5x minus 4y equals 22. See if you can solve this system of equations using the elimination method. I'll give you about 5 minutes to work on it. Let's go back to this question. And let's see if we can solve this using the substitution method. After that, what I'll do is I'll go back and I'll show you how it could have also been solved using the elimination method. I will not require you to do it by a specific method. If I say solve it, I don't care what method you use, except if I say solve graphically, then I'm going to want to see a graph. But if it just says solve this, it doesn't matter which method you use as long as you come up with the right answer. But as I said, once one of your equations says either y equals something or x equals something, it's the easier way to go is to use the substitution method. So what I'm going to do is in my second equation, where I see a y, I'm going to replace it with 4x plus 12. So my second equation is going to become 2x plus 3. Now remember, here's my new name for y, 4x plus 12. I have to put a parentheses there because this 3y means it's 3 times whatever the y is, which in this case we're using 4x plus 12. And that's equal to my negative 6. And now I have a regular linear equation to solve. I have to remove the parentheses. I have 2x. Multiplying everything here by 3 using the distributive property will give me 12x plus 36 equals negative 6. Combining these two terms, 2x and 12x, is 14x plus 36 equals negative 6. I'll subtract 36 from both sides. So that'll give me 14x. Okay, this cancels out. Equals negative 6 and negative 36, which is negative 42. You could certainly use your calculator to do that. Negative 6 minus 36 will give you negative 42. And now divide both sides by 14. And that'll give you x equals, well, 42 divided by 14 is 3. So this is negative 42 divided by 14 is negative 3. So I now know what the x is. To find the y, I'm going to go y equals 4 times, my x is negative 3 plus 12, which will give me negative 12 plus 12, or 0. So I know my x is negative 3, my y is 0. Here's my solution, negative 3 is 0. If I would have graphed this on a piece of graph paper, those two lines would have met at, on the x-axis, at negative 3, 0. There's nothing wrong with getting one of your answers equaling to 0. Does anybody have any question? Okay, I'm going to go back. I'm going to erase this and go back and redo this, showing you that you could have actually used the addition method, the elimination method, to solve this as well. If I want to solve this by the elimination method, then I need both of my equations to be in standard form. The second equation is in standard form. It's got the x, then the y, then the equal sign, then the number. But the top equation is not in standard form because it has the x on the opposite side of the y. I need to get the x on the same side as the y and have the number just alone. So I will subtract 4x from both sides of this equation. And I'm going to put it so the x comes first, the y comes second, the equal sign, and the number. So the top equation in standard form will be negative 4x plus y, this is now canceled out, equals 12. I put that original equation that was in the y equals mx plus b form into standard form. My second equation stays 2x plus 3y equals negative 6. And now I can use the elimination method. Should we eliminate the x or the y? Doesn't really make a difference. We can do whichever we want. Let's say we decide to eliminate the x. Now, actually, I could have just multiplied the bottom equation by 2 because that would have made it 4. But if we're using my method, then I'm going to multiply the top equation by 2, the bottom equation by 4. Remember, I just used the numbers. I multiply this by the 4, this one by the 2. And then I see, since this is already negative and this is positive, I do not have to use a negative sign with it because I will end up with the first one being negative and the second one being positive. That's what I want to end up with. So my first equation comes out to be negative 8x plus 2y equals 24. And my second equation comes out to be positive 8x plus 12y equals negative 24. And when I add this, the negative 8x and the positive 8x, notice one is already negative and one is already positive. They cancel out. 12y and 2y gives me 14y. 24 minus 24 gives me 0. And if I divide by 14, that gives me 0 divided by anything is 0. So my y comes out to be 0. And then I can go back to either one of these equations, let's say this one, and replace the y with 0. If I replace the y with 0 in this equation, I'll get 0 equals 4x plus 12. I'll bring the 12 to the other side. So it'll give me negative 12 equals 4x. That canceled out. Divide by 4. And I get negative 3 equals x. So I have my x is negative 3 and my y is 0. Again, the exact same answer I got before, negative 3, 0. It doesn't matter which method you use. As long as you're careful, you'll get the right answer. Is there any questions about this? Okay, so let's just remind ourselves that I'm around 2 o'clock. You can look for the first test. It's going to be posted on Delta Math. I will give you 24 hours to complete it. And in addition, I will post a homework and
At what time will it be posted? At what time will it be posted? Tomorrow?
in about
The test?
at about 2 o'clock. I'm going to do it right after class.
Okay.
I'll
All right.
I'll probably give you till 2:30 or 3 o'clock tomorrow to do it. So if you can't do it in the afternoon, you could do it in the evening. If you can't do it in the evening, you can do it in the morning. I'm giving you a full 24 hours. It's only 10 questions. Again, make sure that you do it because it is your first test, NARC. Are there any other questions? Okay. I'm going to end this session now. And I'll try and help. Who was it, Kizzy, who had a problem with the graphing on the Delta Math? I'll try and help you with that. Anybody have any questions before I close the session? Okay, then I'll see you on Thursday. Everybody have a good day.